All right, now on to the enzymes. Enzymes are really cool molecules. Now, I'm going to say something that can be not 100% correct, but for majority of the time, all enzymes are going to be proteins. There are some type of enzymes called ribozymes that aren't proteins, but for the majority, 99.9% of all enzymes are proteins. They're typically going to end in the suffix ase. So to give you an example, sucrase breaks down sucrose. So what they do there is they try to match the enzyme with the substrate. That doesn't always happen. To give you an example, like pepsin is an enzyme found in your stomach that breaks down proteins. But they do try to link lactase breaks down lactose. So they do try to link the prefixes and give ase to enzymes. Now, again, not every enzyme is going to end in ase. Just like I said, pepsin is an enzyme; it doesn't end in ase. But those are just again some similarities that we see between the verbiage for enzymes. Now, enzymes are going to do two main things. Enzymes either build things up or they break things down. Okay, that's the only. There are other things that enzymes do, but the two main things are that they build things up, they put things together, or they break things down. That means they split things apart. Some more vocab words that we got to know going forward. And again, a lot of this is review from your 9th and 10th grade biology classes. We have substrate. That is what is reacting with the enzymes. This is the before. This is what the molecule looks like before it reacts with the enzyme. The active site. That's going to be the location where the substrate bonds to the enzyme. The enzyme substrate complex. This is when the substrate bonds with the enzyme at the active site. This is just what it actually forms, and I'll show you images of all this in a little bit. The product here is what is produced after the enzyme reacts with a substrate. Excuse me. So the two things that enzymes do are, again, they break things down or they build things up. In this reaction, we can see the substrate is going to attach to the enzyme, and it's going to become the product. What this reaction also shows us is the enzyme is reusable. It's not used up in the reaction. That's a main point here for enzymes. Enzymes are reusable. Now you can see here, this is an image of an enzyme that is going to split something up. We have the substrate, we have the active site, and we have the enzyme. When they come together, that's the enzyme substrate complex. Afterwards, you can see the product has been split apart. Now on the opposite end here, you can see these substrates are going to match in and fit in the active site. They're going to form that enzyme substrate complex, and that enzyme is going to react with that substrate to form some type of product. This is, again, a reaction where you're going to build things up. Now, if you remember back some of our verbiage from chapter 3, this is a hydrolysis reaction because you're breaking things up. This type of reaction is a dehydration synthesis reaction because you're taking two monomers and you're building up a larger molecule. One of the things we talk a lot about in biology in AP is what's the difference between AP biology and regular biology. This slide here is a perfect example of what's the difference between AP and regular 9th and 10th grade biology. The difference is in 9th and 10th grade biology, I show you very easily that the substrate fits in with the enzyme. What actually happens is, again, when we get a little bit deeper, it's a little bit different. It's not that the substrate just perfectly fits in that enzyme at the active site. What we call it is it's called the induced fit model. What that means is the enzyme doesn't really fit the substrate at first. You can see here it has similarities between the substrate and the active site, but it's not perfect. So what's going to happen is that enzyme needs a little bit of energy that we're going to get from ATP to kind of change its shape to fit the substrate. Now, when that happens, the enzyme will then again change shape and either change that substrate in some way, break it down, build it up, change it in some way. This is called the induced fit model, where the enzyme again doesn't fit perfectly at first, but through a change of shape will react with that substrate, change it in some way, and then go back to its original shape here. One of the last things we're going to talk about is activation energy. Now, we've talked about these diagrams a little bit before when we talked about Gibbs free energy and exergonic and endergonic reactions. If you look here, we're starting with this amount of energy in the reactant and this amount in the product. So we're going to be losing energy here. So this would be an exergonic reaction. Now, with these reactions, there's something called activation energy. I relate activation energy as how much energy it takes to kind of wake up in the morning. This is how much energy is needed for a reaction to occur. Now, without an enzyme, or you can see here a catalyst, you can see there's a lot of energy required for this activation. So normally reactions won't occur on their own. If they do, it's very frequently, or infrequently, I should say. With a catalyst, you're going to lower activation energy. You can see here how this bump right here is a lot lower than this bump. So what enzymes do is they lower activation energy. So they act as a catalyst. They speed up chemical reactions here.